Good morning and welcome to ACER webinar on the amendments to the Grid Connection Network Codes. My name is Urer Gabriel and I will be acting as the chair. We are organizing this event to explain the purpose and timeline of the consultation and amendment processes, as well as to present key changes in the draft legal text of the requirements for generators and demand connection network codes. As to the agenda, we have a couple of presenters today. First, Maria will present the processes for submitting stakeholders' responses to our consultation and the overall timeline leading to ACER recommendation to the European Commission on the Grid Connection Network Codes Amendment proposals. Then Yorgos will present the key draft amendments subject to this public consultation, which will be followed by a Q&A session where you'll be able to pose any questions to us. Okay, so let's move on to the housekeeping rules. Today, we will not be addressing any detailed technical questions regarding our draft proposals. For this, we would like you to use the EU survey, being the main tool used in our consultation. You can use the chat during our presentations or raise a hand during the Q&A session in order to submit any simple queries concerning the consultation and amendment processes. Also, please keep your microphones muted at all times unless I give you the floor following your raised hand. We will upload these slides that you see today and the recording of the event after the event to our website. This is it from my side, and I'll pass on the microphone to Maria to present the consultation process. Go ahead, Maria.
Hello, everyone. Now we will present the process for submitting responses to the public consultation and the timeline for amendments. And just to provide you with the detailed instructions on how to use the NCRFG and NCDC consultation forms to submit comments on ACER proposed amendments, we will give you a short introduction on the EU survey tool and how to use it. Also, please note that you can refer to the detailed instructions in the respective consultation form under the instructions tab. So the process for submitting responses to the public consultation consists of 3 mandatory steps. Step 1 is downloading ACER draft amendments in the Word file provided in the consultation form. You can do it by using the link in step 1 or using background document section on the right panel of the consultation form. Step 2, commenting on ACER draft amendments through the consultation form and adding alternative text proposal to the table if you have any. And step 3, uploading the alternative amendment proposals to the entire NCRFG and NCDC text using the track change mode in the ACER draft amendment file that you previously downloaded from step 1. When using consultation form, please keep in mind that the form follow the structure of the amendment legal text of NCRFG and NCDC respectively. And this means that the paragraph numbering of the form reflects paragraph numbers of amendment legal text. Still, stakeholders can comment on the deleted paragraphs, articles, or titles, and they will be marked as deleted. And new articles and titles will be marked as new. And now moving on to the consultation form itself, please use the form in the following way. You can see on the picture the sequence that you have to follow to correctly fill in the table. First step is to leave comments on the ACER draft amendment proposals in the text, in the table, sorry. Second, propose if you have any alternative wording of the relevant provision. Please also make sure that it is the same as you provided in the Word file. Third step is provide your proposals, again, if you have any, for adding new provisions to the relevant section of the NCRFG or NCDC in the second table below, as you can see on the picture. Again, same as you provided in the Word file. And step 4, upload figures or tables if necessary, but please note that text input should be provided directly in the consultation form. And still, if there is no comments or no amendment proposals, the relevant cell or even the table in its entirety can be left blank. And lastly, regarding the consultation form, where you have proposals for alternative amendments to the entire NCRFG or NCDC, please upload the Word file downloaded from step 1, as we mentioned before, that contains all your alternative amendment proposals in the track change mode. And you can upload it to the file upload section in the pages panel at the top of your consultation form. And please rename the file with your stakeholder's name, meaning ACER draft RFG and your stakeholder name, or ACER draft NC and your stakeholder name. Also, in the same section, you can upload any justification documents that you might have or any applicable files you want to share with us. And still, to highlight once again that we would highly appreciate if you can make sure that the alternative text proposals provided in the consultation form are consistent with those in the Word file you're uploading. Of course, to the extent possible, because the character limitation of each cell is maximum 5,000 characters. But still, it would help us to go through the alternative proposals without losing any input. So that would be very, very appreciated. And now I will give floor to Yorgos to present the timeline of the amendments. Thank you.
Thank you, Maria. Let me just take control of the presentation. I hope you can hear me well. Good morning, everyone, to everyone who is connected. So first of all, just to talk about the amendment process, as you are well known from previous workshops and presentations, we are right now at this point where we are have launched our public consultation for 10 weeks. And we also have this public webinar to complement our launching of the public consultation. As you all know, that we aim to finalize the amendment and recommendations after our public consultation at late Q3 2023. And then we have, of course, our own internal process to go through. Decision phase will be Board of Regulators approval, and then at the end of the year, submission to the European Commission. And we have also concluded some public workshops, and you may be aware. On the 17th of April 2023, we had the electromobility, power to gas demand units and heat pumps workshop, where we had presented our draft proposals and thinking at the time. On the 10th of May 2023, we had the rate of change of frequency and grid forming capabilities workshop. And then on the 11th of May, we had technical requirements for electricity storage. And you can also find the materials in the link provided in this presentation. And then, as I said before, we are now in this phase of the public consultation on ACER proposal. The public consultation has already been launched on the 17th of July, 2 days ago, and it ends on the 25th of September 2023. And Maria has already provided some information regarding how to use the tool and what is the process to provide your input to the amendment proposals. And of course, this covers the network code requirements for generators and the network code demand connection. And now I will go through some main parts of our amendment proposals, draft amendment proposals. that are included in legal text that we have attached in the public consultation survey tool. Regarding the network code requirements for generators, we have selected here a few new recitals that are included in our legal text. Even some of those are not new in the sense that they are additions to the existing recitals. That is also based on the feedback we have received from stakeholders in the previous public consultation last November. So we are aiming to clarify the notion of synchronous power generating modules. We have changed slightly the text of the current text in the current network code for requirements for generators. So right now it reads as it is here in the presentation. So an installation containing a set of synchronous machines that cannot be operated independently from each other should be assessed on the whole capacity of that installation. Also, there is an introduction of the notion of integrated energy storage, which of course was not previously in the current version of the RFG. So we have electricity storage, which is integrated to a power generating module, whether it's non-synchronously connected to the network or connected through power electronics, and it's used solely for the purpose of meeting the requirements of this regulation, should be considered as part of such module, and its capacity should not count towards the power generating module capacity. So effectively, storage that is integrated and is used for any of the requirements of the regulation should not count towards the determination of significance of this module. And also another example of our additions is capturing autonomous energy islands. So effectively, we have this recital that the power generating modules are subject to this requirement unless such energy community or another entity or a form of system users aggregation constitutes a fully autonomous energy island. And this actually follows the backup rules that are already included in the RFG, and you can see it in our legal text proposal. Now, moving on to electromobility. Some of those slides you will see have already been presented to our workshops in April and May. So for completeness, we are presenting it now as well. So we have new definitions, as you can imagine. We have V1G electric vehicle, V2G electric vehicle supply equipment, and electrical charging park. And of course, there are other definitions included in the legal text, as this list is non-exhaustive. And regarding the applicability of NCRFG for electromobility, so we'll have bidirectional electric vehicles and associated bidirectional electric vehicle supply equipment. And we have three different types for these devices. So we'll have V2G type EV1, which is from 0.8 kilowatt to up to 2.4 kilowatt. And we have V2G type EV2 from 2.4 kilowatt up to 42 kilowatt. And we have type EV3 from 42 kilowatt and capacity up to 1 megawatt. And the first two types, EV1 and EV2, we have a new article 13A with exhaustive requirements for both EV1 and EV2. And you can see a list of these requirements here, which are frequency and voltage ranges, rate of change of frequency with stand capability, data interface for charging infrastructure, autonomous connection, reconnection, limited frequency sensitive mode for under frequency for EVs, and over frequency for EVs, and then of course voltage robustness, fault right through capabilities. And for EV3, we have a new article 14A, which again, it's a new article with requirements that are effectively the ones for type EV1 and EV2. And in addition, we have some voltage ranges for medium voltage, high voltage, and extremely high voltage, extra high voltage, and system management provisions, reactive power capabilities, post-fault active power recovery, and grid forming capabilities. Just to reiterate, as in the workshop, that beyond 1 megawatt, the electric vehicle and associated supply equipment are regarded as electricity storage module and follow the provisions for electricity storage modules. Now, some examples as far as the aggregation application of technical requirements. So the idea is not to aggregate the equipment. So we can see in example 1, 2, 3, you have one electric vehicle and associated supply equipment, which is 2 kilowatt, which constitutes EV1 type. And then we have again another electric vehicle plus supply equipment of 2.4 kilowatt, which is according to the ranges is CV2. And then we have an EV3 type EV and supply equipment of 200 kilowatts, for example. And then we have the notion of electrical charging park, which effectively combines these EV together and supply equipment together, but not regarding the technical requirements of each individual one. So each one is classified as EV3, for example, in this case, in example 4. But if it's many of those connected under the same connection, behind the same connection point, then they are classified as electrical charging park, and they have some provisions for the park itself. And then again, we have here in example 5 that a charging park can only include EV types of the same type and not different ones. So you have here behind the same connection point an EV2 electric vehicle and supply equipment, and also a number of EV3 and electric vehicles and supply equipment. And these are going to be different charging parks based on our proposal. Regarding the compliance for electromobility and these types, again, they follow the same ranges as before, but we have here for EV1, it's a use of equipment certificates only and no operational notification required in the network code RFG, although national connection rules may require a connection agreement. And then we have EV2 type. We have operational notification procedure is required for this, and requirements to demonstrate the compliance. It is Article 30A, a new article in the RFG. And that is because there could be potential dynamic or fixed power limitations for these devices due to their size. And also we have an EV3, which again, they require operational notification procedure and the requirements to demonstrate compliance with the new Article 30B in the RFG. And again, just to reiterate that beyond 1 megawatt, B2G and associated charging point installation follow operational notification procedure of electricity storage modules. Moving on to the requirements for storage. We have a new definition. Electricity storage module means a synchronous power generating module or a power park module, which can inject and consume active power to and from the network from electricity storage, excluding pump storage hydro. And effectively, this makes the electricity storage module a power generating module. And of course, it's subject to the technical requirements laid down in the network code RFG. And as I mentioned before, bi-directional electric vehicles and associated supply equipment beyond 1 megawatt follow the electricity storage module requirements. And there are some additional requirements for these devices based on the underlying technology that they are able to provide some more capabilities than the traditional power generating modules. And of course, the electricity storage modules should support the system both when injecting and consuming active power. And these are some requirements for storage. So we have the general requirements for all PGMs, power generating modules, and we have requirements for all synchronous power generating modules or requirements for all power park modules. And then we have additional requirements for electricity storage modules So we have limited frequency sensitive mode for over frequency and under frequency response, adjusting injection or consumption, modulation of active power input or output following the instruction, and electricity storage module provides capabilities based on their maximum energy storage. And of course, it is the possibility to switch between injecting and consuming is also required. Moving on to other proposals, we have the pump storage hydro power generating modules proposal, and this is also based on the final report of the pump storage hydro expert group, which was established under the Grid Connection European Stakeholder Committee. And then you can find the provisions in the legal text in our proposal. Determination for significance. Again, the proposal is based on the final reports of the mixed customer sites expert group, again established under the Grid Connection European Stakeholder Committee. The application of voltage criteria, which was something that has been mentioned before, will now apply only above a default capacity threshold of 10 megawatt. And however, TSOs may propose to change this threshold within a range of 5 megawatt and up to the C and D upper limit for capacity threshold. And also there is a proposal to limit the upper threshold for capacity for A and B to 0.5 megawatt for continental Europe synchronous area. Regarding significant modernization, we have clarified the rules for significant modernization, and also there is a definition of coherent criteria across member states, such as increase of Pmax, change in frequency stability, change of components. And also TSOs should develop proposals for defining the significant modernization and applicable requirements. Regarding the type A power generating modules and the technical requirements for those, again, the proposal is based on the final report for the expert group on baseline for type A PGMs. And there is a requirement to equip PGM with a communication interface to enable reduction of active power. Previously, that was seizing active power within 5 seconds, and that has been replaced. And also, based on the new needs in the system, there are new additional technical requirements for type A PGMs, for example, like fault right-through capability, which for SPGMs is non-mandatory and for PPMs is mandatory. Voltage control system, which is mandatory, reactive power capability, non-mandatory, and grid forming capability, which is a new requirement, non-mandatory. And based on our policy paper, we have provided some provisions for extreme weather hazards that we believe that are important for the future and for the resilience of the weather resilience of the power generating modules. And there is a new non-mandatory requirement that considers the specificities of generation technologies as well as the geographical and climatic particularities of each member state. And you can find the actual legal text proposal in our draft document. Now, regarding the mixed customer sites, there's a new recital to tackle units of different classes behind a single connection point. And so the idea is not to aggregate types of devices that are of different technologies. So you can see in the first example, this should not be possible to do in the new RFG. So this should not be a single power pack module. We're having, for example, an electric vehicle and supply equipment, solar panels and storage. So this should not be combined as one power pack module. Whereas the other two examples in the middle and to the right, you can see that these can become PPM1 or PPM2, PPM3 on their own. And also in the third example, you can see, for example, 4 storage devices that can be aggregated as one power pack module. In that case, this is an electricity storage module. Now, regarding the rate of change of frequency with time capability, and following discussions and with the system operators and relevant stakeholders, we have decided to include in our legal text a draft proposal for how to tackle this requirement based for feedback we received. So we have for all PPMs type A, B, and C and D, we have these new requirements for rate of change of frequency, and also we have a new frequency against time profile that they need to comply with. But regarding the synchronous power generating modules, below 400 megawatt, we have somehow reduced requirement, so they should comply with the 2 hertz per second rate of change of frequency withstand capability. But for SPGMs above 400 megawatt, the threshold for compliance is and for the technical requirements is 1 hertz per second. Coming to the grid forming capabilities, again based on our workshop in May, we have a new provision for the types. So it's effectively a 7 source-like behavior, which is the instantaneous AC voltage characteristics of the internal source has to be capable of not changing its amplitude and voltage phase while voltage phase angle steps or voltage magnitude steps are occurring at the connection point. This is effectively to replicate the current behavior of synchronous power generating modules. And you can see here this behavior for type A is non-mandatory. And then when we move to type B, C, and D, they inherit this behavior as mandatory. And then there are some additional requirements, for example, like synthetic inertia for type B, and limitation of transient frequency deviation under high frequency conditions. And for electricity storage modules of type B, there is also the contribution to limiting transient frequency deviations under frequency conditions, low frequency conditions. And then for type C, we have the contribution to limiting transient frequency deviations under low frequency conditions in addition to the high, and also we have the possibility to require an additional energy storage. And these requirements are mandatory. And some more details regarding the grid forming, and based on the input following our 10th of May public workshop. So for type A and B PPMs, the relevant system operator may specify the activation of grid forming mode is subject to necessary adaptations to the system operator's network and operating and maintenance procedures. For PPMs with Pmax maximum capacity below 10 megawatt, the power park modules have the capability to activate or deactivate grid forming mode. And also for all PPMs, the relevant system operator in coordination with DSO shall specify the temporal parameters of the dynamic performance regarding voltage control. So that is it for the RFG. So moving on to the network code demand connection. So we have some new devices or equipment in the network code introduced. So we have the V1G electric vehicle and associated unidirectional electric vehicle supply equipment. So this is only charging electric vehicles above 0.8 kilowatt capacity at all voltage levels. And we also have heat pumps and power to gas demand units above 0.8 kilowatt also at all voltage levels. And these new devices, there will be new article in NCDC with exhaustive requirements, and you can find these technical requirements, a list of those in this slide, such as frequency and voltage ranges, rate of change of frequency withstand capability, limited frequency sensitive mode for under frequency for consumption, and also fault right through requirements for V1G electric vehicles and supply equipment, and also power to gas demand units. Regarding the compliance of these units, so for all these types and a connection point below 1000 volts, and there is a need for a requirement for only certificate equipment certificates. And then we have for connection point above 1000 volts, there's still the requirement for equipment certificates for electric vehicles, V1G electric vehicles and supply equipment, and also for heat pumps. However, for power to gas demand units above 1000 volts, then the operational notification procedure using the demand unit document specified by the relevant system operator is required. And that's the end of my presentation.
Thank you, Yorgo. So let me take the control. Okay, good. So we have received a plethora of questions via the chat function, and I propose to first cover these. And after that, we can move over to, let's say, orally expressed questions via raising a hand. So, but first, let's go to the questions which are in the chat. So we'll try to go one by one. Please do not submit any further questions in the chat. You'll be having a chance um, to raise a hand after we finish this. Already received questions. Please do not submit any further questions via the chat. Let's leave the rest of the comments or questions for the oral part. Okay. The first question was from Mark, and it was regarding the use of both our consultation tool and Word document with track changes. And Yorgos already responded that this is correct. Stakeholders are invited to submit their comments both via the tool and the Word with the track changes. Why so? Because it's for ACER very difficult to operate just with one or the other approach when there are overlapping suggestions from stakeholders, and we use the tool results to find the overlapping let's say proposals from stakeholders, and then for details we usually rely on the Word document with track changes to have a concrete let's say views into what the stakeholders propose with regard to the changes. Then there was a question on the materials. As I responded in the chat, yes, the slides and the recording of the webinar will be published on the ACER webpage shortly after the end of the consultation. Then the next question is, what is the basis of the V2G capacity intervals? Yorgos, you want to take this over?
Yes, thank you. You might remember, I don't know, you have attended the workshop on electromobility. The basis is basically how these devices are connected to the system or to the electrical connection point. So the idea is that the VV1 effectively are connecting, could actually connect directly to a domestic plug, or through a very simple wall box, whereas the other part, which is the EV2, effectively covers the devices that are mainly connected through AC wall boxes. So effectively the converter is on the side of the electric vehicle, and the EV3 is effectively trying to capture mainly the big ones, which are normally should be connected through DC. So effectively, the wall box is a DC, or the converter is on the wall box, and then the electric vehicle provides only the battery, effectively the storage. So that's the idea behind the ranges.
Thank you. Then we have a question from Christian, whether the example for EV comprises of vehicle plus the electric vehicle supply equipment, and not just the supply equipment. Yes, it's both the vehicle and the supply equipment that need to comply, because for EV1 the converter is on board of the vehicle itself. Next question is, will the rule from Mark Stencils, will the rules once approved and issued be applicable to new installations only? Yes, this is correct. And it's you can find the relevant provisions in the beginning of the network code, both network codes. So there is a possibility to have um, let's say requirements of this revised network codes be applicable to existing system users, but there is a quite onerous process at the member state level, including a cost-benefit analysis in order to do so. Next question was from Javier. Is the compliance at equipment level, charging park level, or connection point? Yorgo, you want to take this over?
Yes, the compliance is always a connection point. So it refers to the equipment connected, but it's at the connection point.
Okay, thank you. Then two questions from Tobias. First one, where is the legal text concerning the 1 megawatt threshold for electric vehicle supply equipment being considered as the electricity storage module? Please refer to Article 5.1c. Second question. So, for example, 12 pieces of electric vehicle supply equipment with a capacity of 10 kilowatts are all considered as type EV2. Yorgos, could you please answer?
Yes, that's correct. Each one of 10 kilowatt will be considered as type EV2, so they will not be aggregated to become EV3s effectively.
Okay. Then it's a question from Vladimir. When talking about connection point, do you mean primary substations or also medium voltage, low voltage substations? When we can speak of the connection point, you will see in both network codes, we haven't changed that. The connection point is defined in the connection agreement. So it's not related to the substations as such, but to the agreed point in the electricity network as to where the connection point is defined. So it's more not from a technical point of view, but from a contract point of view. Question from Mazik. How will power generating units with different generation technologies that are connected together through one power electronic system be treated? For example, PV, wind farm, storage installed behind one inverter. How this will be treated? As one ppm or 3 different ppms? Yorgos, do you want to take this one?
Yes, essentially the requirements normally are on the converter side. So it's the converter effectively is the one who is interacting with the system and the grid. So if there is one single converter and there are devices behind it, then of course it will be one ppm, because the converter has to interact with the grid and whether there is a disturbance in the system, they need to react to the disturbance.
Yeah, thank you. So it's not about the primary source technology, but from the technology that is seen by the network, which is the converter in this case.
Yeah.
Yorgo, would you be fine with taking Dimitri's question as well? Because it's about the evaluation of stakeholders' comments.
Let me see if I can try to see in bit bigger because I cannot see what.
Yeah, it's difficult to resolve the question because it doesn't refer to any, doesn't have a concrete reference. It's just a general comment. I don't know.
Um,
Screenshot, okay.
yeah, I mean, first of all, regarding this, we are not putting references to specific standards in the RFG. Standards can change, whereas the RFG or as a legal text, European legal text, can be there for 10 years. So we should refrain from using specific standards to the RFG. And of course, standards can be taken into account, and it's already included in the legal text and can be considered, but specific references to standards cannot be included in the legal text.
Thank you, Yorgo. Can you also perhaps take the next comments and questions from stakeholders as they appear in
Yes.
the chat? Thank you.
Yes. So synthetic inertia ppm is mandatory from type B. It is mandatory for type B, but you will see that there is a difference between type B as included in the slides and the higher types. Whereas for type B, it is using effectively the whatever storage is included in the device, what the inherent storage capabilities is called in the legal text. Whereas for higher types, it's possible for the system operators to require or request additional storage devices. And the next one from Francois, how do you consider vehicle to grid versus grid forming? There is a legal provision that the EV3 V2G electric vehicles and associated supply equipment could be requested to have grid forming. So in that sense, there are devices with storage included, so they could be considered from the system operators if needed be to have the grid forming capabilities. Another question. So electricity storage modules are treated, I suppose this is treated as ppm in the slide regarding ROCOF requirements. Yes, that is correct. So they follow the power pack module. And when there is a difference or there are additional requirements, this is included in the legal text. Christian, also what happens when a single supply equipment supplies up to 3 vehicles and can operate from EV1 up to EV3? This depends on the supply equipment. I mean, if it's a one converter, then 3 vehicles cannot be connected simultaneously. If there are 3 different converters and they have different sizes, then of course they will be classified according to the range that they have. But if it's a single converter and there is a maximum capacity for this single converter, then of course you will take requirements according to the maximum capacity that it has. Another question: in case we have PV, wind, suppose this is wind farm, and storage system, should there be 3 different inverters for each one of them, or one big inverter to control the logic for whole park? As we said before, I mean, if it's a different, if these devices, these prime sources of energy are connected with different inverters, then they will be classified as different power park modules, and they will have the requirements based on their capacity. If it's at one single inverter and the prime sources are aggregated behind and controlled. Of course, they cannot be controlled independently because the inverter is the same. So this could be one Power Park module for that. And Yasin has a question about what about data centers. Well, data centers can still be considered in a national legislation. We understand that data centers are not in all member states connected, and of course, through the connection agreement in a national legislation or with the connection agreement for the system operator, there could be some additional provisions for these devices if need be. We don't think that there is a need for a European approach for these devices. Will there be a text draft for each topic as we had for the workshops, which we could comment on? Well, as Maria mentioned before, there are two legal text proposals, one for the requirements for generators and another one for a network code demand connection. And you can either comment or propose amendments in one or both of them, depending on what you consider. And will feedback from other expert groups still be considered if proposed during the consultation? Of course, we will consider all proposals within our public consultation. Do the amendments of the network codes include modifications to facilitate flexible connection, meaning connections other than fixed contracts for both generators and demand? If I understand correctly, this probably is a market issue. This is not a connection issue. The requirements for generators and demand connection does not go into detail or regarding contracts, fixed contracts, or any flexible operation of these devices. So in that sense, it's out of scope, if I understand it correctly. When is it expected to enter into force? I mean, as I mentioned before, our plan is to recommend our final draft proposal to the European Commission at the end of the year. And then, of course, after that is on the hands of the European Commission to follow the procedure and the process that they have for the amendments up to the point where it becomes law. I wouldn't be able to comment specifically on that, but I would assume that sometime next year could be the whole process could be completed. The requirements from Eric, the requirements for new areas such as rate of change of frequency and grid forming can change in the near future due to evolution of technology. How will ACER handle this? A classic derogation at member state or an EU derogation? Regarding the ROCOF, I mean, the idea is, first of all, to have the new requirements as ENTSO has proposed for PPMs, for example, up to 4 Hz per second, because the idea is that in the future, the system inertia will be lower and there is a need for devices to be able to support the grid up to that level. However, we have, based on discussions and our understanding, is that there are technical limitations for certain types of synchronous power generating modules, and that's the reason for the differentiation between those two. So for power pack modules, which the expectations in the future, there will be more of those connected in the future compared to the big synchronous power generating modules as it's currently is the case, or has been the case in the past. So we have these additional requirements with higher rate of change of frequency capabilities to tackle this evolution of technologies in the future. However, taking into account the technical limitations of the existing technologies like synchronous power, traditional power, synchronous power generating modules. Regarding the grid forming, again, based on feedback and proposal from the expert group, we have tried to introduce certain clauses in there to tackle these unknowns in the future regarding the use of grid forming, and we believe that it introduces certain a balance between the requirement to have this the capability in the future, as has been demonstrated by many studies before, and also the need to take into account that this is a new requirement, a new provision, and might need certain things to change in the future based on the implementation guidance by NB. Slide 24. There is a need for a coordinated voltage control of all PPMs in the mixed customer site sharing the same transformer. Again, we're talking about connection requirements. If there is a power pack module defined as such within a mixed customer site, it will see the responses or the disturbances from the grid, and it has to respond. And of course, everything is at the connection point. So of course, what the system needs is the connection point voltage and frequency to be respected. So in that sense, if there is a coordinated voltage control of all PPMs in mixed customer site, then of course, I don't think this is excluded from the legal text. It can be taken into account because, of course, as I said, the voltage at the connection point is important from the system point of view. Regarding to this answer, if storage has higher capacity than PPM, we treat all equipment as ZSM. I mean, storage, as mentioned before, is actually based on the determination of significance in Article 5, based on the capacity. So depending on the capacity of the electricity storage module, it will have the type according to the capacity thresholds defined in member states, and it will have to follow the requirements based on that type. Will it be possible to mention that data centers are out of scope? I mean, if they are not covered in the RFG, then of course it's a member states possibility to introduce any additional requirements in their legal legislation. I don't know whether it is a need to actually explicitly mention that they are not covered, but we can have a look at it and see whether there is a need from the legal point of view to actually have this kind of provision. And if there is a need from your side, maybe you can actually include certain provisions in the legal in the public consultation. Requirements shall also be applied in consumption mode and CRFG requirements such as reactive power control and fast fault current injection. Again, if we're talking about storage devices that are able to operate in consumption and generation mode, then of course requirements are going to be needed in any mode of the device, and of course you will see in the legal text if there is something that is not possible, then this is excluded. But in general, all requirements of the RFG for bidirectional equipment like energy storage that are able to provide consumption and generation should actually follow and comply with all the requirements. Flexible connection contracts are not a market issue. They should normally be a description of technical requirements and how and when the connection is made flexible in the connection code. Whether this is remunerated or not is a different story. I'm not sure I understand the flexibility on the connection code. I I mean, in the connection agreement, there is the maximum capacity based on the connection agreement, and this is based. This is used in the determination of significance of this type, and then of course it follows the requirements afterwards. I mean, maybe you can clarify a bit more the question, as I'm not able to understand exactly what is the issue here. Another comment regarding significance of the power generating module. Do I understand correctly that the proposal is to harmonize A and B threshold in continental Europe? No, that's not what it is proposed. This is actually reducing, the proposal is to reduce the maximum threshold for type A and B from 1 megawatt that it's at the moment to 500 kilowatt. So there is still the possibility to have to define a member state to define a threshold below 500 kilowatt for between type at A and B. Slide 23, are the extreme weather hazards for different state members already drafted, or it can also be proposed by national TSOs? Yeah, you'll see in the legal text that it's not drafted at the moment. It is a proposal for to take into account weather hazard provisions in their implementation, the national implementation. And another question from Alexander. In case of multiple type A installations behind one single connection point where they are summed up, power is above type B threshold, are they then classified as type B? Again, if they are the same technology and they are aggregated as one power generating module, and of course the aggregated capacity will matter to determine the significance of this device as a aggregated one. If it's not, if there are different types of ppms connected there of course each ppm will have to base their type according to the maximum capacity of this power park module. So if there are many small installations that are aggregated in a single power park module or synchronous power generating module, then of course the aggregated capacity will matter or for the determination of significance. Another question, can the communication interface be with a dedicated device at the connection point that reduces active power at the connection point and not with every single device installed? Again, if we're talking, because the requirement for generators talks about modules, so we can have different modules within behind a single connection point, or we can have a single module connected in a single connection point. So the requirements are at the connection point, but they have to be provided by the module itself. So the module itself has to reduce, for example, active power, because if there are many modules within behind the single connection point, all of them have to respond to any disturbances at the grid. So if there is a need to reduce active power, if there are two modules behind the single connection point, then of course all of them have to reduce active power, and of course this will be sensed or seen at the connection point from the system point of view. But if it's one single connection, a power pack module, for example, at the connection point, then of course it's the same. But the module has to respond and has the requirements for these technical provisions. In DCC, ACER mentioned several times providing demand response services. Do you mean to public grid operators, or how do you define demand response services avoiding when you're active on the day ahead, intraday forward energy markets? You are suddenly subject to the requirements, although not that this could become a barrier for demand to provide a service to grid operators. In my view, this should be covered in the product specifications. Demand response services is exactly the kind of services that are in the current network code demand connection. As you are aware, there is the idea to move these services to the system operator guideline. However, until this is done, they are still needed and required to be included in the current text, and that's the reason why they are there. Effectively, they follow the current logic of the network code demand connection. The synchronous power generating module point still doesn't clarify if its SPGU should be treated as SPGM as long as they are independent from each other, or if a group of SPGUs connect to the same point of connection, they should be treated as a single SPGM. I mean, at the moment, the legal text doesn't specify anything about SPGU. So the unit, SPG, synchronous power generating unit, is not included in the current legal text. So we're talking only about modules at the moment. And the module can have a different many units, synchronous units behind it, as long as they are not independently controlled. So at the moment, there isn't any provisions about units. Do storage requirements apply to type A connection as well? When you say type A connects, type A is the power generating module. So if there is a type, if it's a type A power generating module, then of course any requirements for that module, whether it's a storage device, a power pack module, or synchronous power generating module, we have to comply with the requirements of the type A. Is there any work going on to have a one unified type A, B, C, D definitions? Currently, they are different for each region. No, at the moment, we are not proposing to have a unified. I presume you're talking about the thresholds, not the definitions. We're not proposing at the moment to have unified A, B, C, D thresholds. We are minded, we understand that there are specificities in member states regarding especially the higher types, and we are not proposing at the moment to harmonize these thresholds for all types. Questions from Q&A: how is integrated energy storage to be understood? This is essential for reading this requirement. I mean, for example, there could be a case, for example, in the grid forming requirements, where there is a need in higher types like C and D, that the system operator can actually request an additional energy storage because of the additional requirements for grid forming for synthetic inertia. So in that case, if the storage device is integrated within the power pack module and is used only for the requirements for the device to provide requirements for grid forming, then this effectively is an integrated storage equipment, and they should not be treated as a different energy storage and also aggregated with the capacity of the converter of this device. So that could be an example of integrated energy storage. However, if this energy storage is independent from the actual power pack module and used for other purposes as well, then of course this can be tackled as a single ESM and then covered as an individual one for the requirements. Yes, so for example, if it's a whatever capacity of the energy storage, if it's used for the requirements of this this regulation, then of course for the determination of significance, the maximum capacity of the power pack module is only used. how to deal with DC bidirectional chargers of 7 kilowatt. Can we apply equipment certification for such mass-produced devices? Again, in the RFG, you might have heard that the idea is to tackle this where the converter is based. But however, in our legal text, there isn't really anything to exclude DC chargers being on EV2 types, because we don't really explicitly say that EV2 is only AC and EV3 is only DC. So and that's the idea effectively, that we are combining the electric vehicle and the equipment, the supply equipment. So the requirements are applicable to both. So if there is a charger, a DC charger, and of course it's used, then of course the requirements will be applied to the DC charger. And if the charger is on the vehicle side, then of course the requirements will be applied to the vehicle, but it's not specified in the current RFG proposal, and that's the reason why it's not specified. Yes, from Basiliki, yes, it is possible. I think it's after we conclude with the questions in the chat. I think it is possible to raise a hands, and you can take orally describe and your question. But I think if we're talking about, I mean, the current RFG, it's talking about the maximum capacity, because we're talking about technical requirements. If the capacity, if the module is able to go up to maximum capacity, then it has to comply. It has to comply with the requirements based on this max capacity. If there is flexibility within the connection agreement to go below that capacity due to limitations in case of operational constraints, this is an operational issue, and it's not a part of the connection agreement or connection code. For the 110 kilowatt, I presume this is the voltage threshold. There is now a 10 megawatt threshold introduced. Is this threshold per technology? As type B, C, D is defined per technology. This is per module. So it's if the module is below 10 megawatt or whatever it is the threshold, if the TSO decides to change that based on the ranges that is introduced in the legal text, then it will be this for the module. I mean, so it could be per technology in the sense that maybe the module includes underneath only same type of technology, but the idea is to actually have the threshold for the module itself, and that's where the determination of significance comes to. Do we consider photovoltaic and wind farm and same technology? No, the idea is that these are different technologies, and if they have different converters, they should not become aggregated together. So it's if you have 5 photovoltaic panels with a single converter and 10 wind turbines with a single converter, they should not be aggregated together, all of those, for the determination of significance. I believe this is the same question as before. Up to now, it is still subject to research if photovoltaic is able to be equipped with grid-forming inverters, especially in low-voltage grids. Do you have other information? No, at the moment, we don't have any information on that. There will be time, of course, there is the time for the legal text to be go through the process in the European Commission. Of course, there is also a grandfathering provision in the current RFG and also in the proposed RFG. So there will be some time for the stakeholders, the manufacturers and also the system operators to define what are the requirements for grid forming for these devices. Regarding grid forming capabilities for type A, it says that it needs to have the capability to activate and deactivate grid forming mode. Would that mean that TSO and DSO may need to request certificates for the grid following mode and grid forming mode? Our understanding is that the grid forming requirements are on top of all the other requirements. So in that sense, they will need to have grid forming certificates or demonstration for compliance. And then if grid forming is not used, then of course it reverts back to all the other requirements that are needed for a normal grid following. In that sense, they don't have to comply um, to provide these grid forming requirements, but all the other requirements that are there in the current RFG or the proposed RFG will have to be complied with. And the idea actually for this possibility to activate and deactivate is actually based on the DSO's proposal. And we feel that it could benefit also the user and because in the occasions where there are issues with grid forming devices, if there is no possibility to deactivate this mode, then of course these devices have to be offline, become offline, because if there is a need, if there's an issue or there's some kind of coordination issues or between these devices, then of course these need to be offline. Whereas if there is a possibility to deactivate this mode, then these devices can still contribute with the other requirements to the system, but not with grid forming. In relation to the previous questions, do storage requirements apply to type A connection as well? I mean, applicable to residential storage units? In our legal text, there isn't really a residential storage unit. There are storage units that are defined as electricity storage modules based on their capacity, and then they have to comply with the requirements for whatever type they are determined, like type A, for example. Will local limits and curves should be downloaded down to the inverter? Or could the electric vehicle supply equipment plugs can be considered as a system and then deals with only known local curve limits? I'm not sure I completely understand the question, but as we said before, the requirements as they are written in our current legal text proposal are about the electric vehicle and the associated supply equipment. So if the inverter is on the supply equipment side, then all the requirements, the limits and the curves will have to be respected from the inverter side on the supply equipment. But of course, if the device is the electrical vehicle has the converter on the vehicle side, and of course they have to be they have to comply with requirements from the inverter side on the electric vehicle as well, because they could be connected to a AC wall box where the inverter is actually used from the electric vehicle. When an electric vehicle does re-injection, okay, that has been answered. For example, in a charging station with 10 cars are charging, when it receives a command to reduce power by 50%, it is not possible to stop charging 5 cars, but you have to reduce each of the 10 cars charged by half. Yes, I mean, as I said before, if there are 10 cars charging, there will probably be 10 connected to 10 supply equipment. And of course, wherever the inverter is, if it's a DC supply equipment or if it's an AC supply equipment, then the inverter of the car, the electric vehicle, or the supply equipment will receive the signal, and and it has to comply with the reduction of power. So it's not like stopping. That's one of the reasons why we don't aggregate electric vehicles and supply equipment in that sense. So it's the signal will come to the specific supply equipment and electric vehicle. So in electric vehicle charging park can aggregate cars if the controller at the connection point can cope with the rules of the aggregated type certification. As we said before, the charging park is a notion used for the owner to introduce or the system operator to introduce some additional requirements. But as we said before, we are not up to 1 megawatt. We're not aggregating charging columns or charging equipment and electric vehicles. So in that sense, each individual electric vehicle and supply equipment is considered on its own and for the determination of significance. Some of the proposals made by stakeholders in the previous consultation appear to have been either misinterpreted or completely dismissed, and we now have changes to the legal test that exceed the capabilities of some technologies. Again, I mean, if there is a misunderstanding or a misconception, feel free to go into our legal or our public consultation and provide your feedback in there. So unfortunately, the question was not answered. If I have 50 megawatt PV, 20 megawatt energy storage limited to 50 megawatt production and 20 megawatt consumption in a common park control. Is this a 50 megawatt PPM and 20 megawatt ESM, or 70 megawatt PPM and 20 megawatt ESM? Again, we're talking about what is included in as maximum capacity in the connection agreement. What you're saying here, if it's a 50 megawatt PV and a 20 megawatt energy storage under behind the same connection point, and they are different independent ones, so two different converters for both, and the maximum capacity of the PV is 50 and the maximum capacity of the energy storage module is 20, then these are two PPMs, one 50 megawatt and one 20 megawatt. And the requirements should be applied based on their capacity, this maximum capacity, and the type that they are going to be determined. The consequence is that you cannot integrate storage in existing PV installations without extending the grid connection capacity, as 70 megawatt must be applied, i.e. LFSMU situations. If it's existing PV installation, these are not covered in the new RFG code. We're talking about new installations coming in force after the legal text is in force, and then of course there's the grandfathering period as well. So we're talking about new installations mainly. What we have one unified controller our point of connection controlling several converters, even though we have different PV converters, wind turbine converters and energy storage behind the point of connection. Can this be considered as one PPM? Again, if they have different converters and there are different technologies, the idea is to have them as different PPMs, because you would not want to aggregate everything under a single converter. If they are independently controlled, and of course they will sense all of them the converter, the disturbance from the system, then they should respond and support the grid independently. I don't know if there are other questions.
Thank you, Yorgos, for exhaustively covering the questions received during the chat. So I'm opening now the floor for people to raise a hand. so that we can also address your comments orally. Tony, you've been first. You can perhaps unmute yourself, or we can help you if you have troubles. I see your mic is
Thank you.
unmuted. Yeah, go ahead. Thank you.
Thank you. Yeah. So if I could go back to the mixed customer site slide, I may have misunderstood Georgios at the time, but did I understand you to say at that slide that if there were different technologies that would force different connection points, or did I misunderstand what you said there?
No, no. The idea is not to force different connection points. It's that when based on the definition of park park module, that we define a park module should not include should not aggregate different types of technologies. So in that sense, it could be the same connection point, but it could be, for example, in the example in the middle, 3 park modules under the same connection point.
All right. So you meant for aggregation. Yeah, the discussion you've been having. Okay. Thank you.
Yeah.
Thank you. Michael, you're next.
Yes, thank you. Can you hear me?
Yes.
Yes. Thank you for all the answers. They're very clear. Ulrich, there's one topic that was not covered. You know, I've been discussing this a lot. There's a discrepancy between DCC and RFG because one is on site level and the other one is on equipment level, so machine level. There are in many cases some issues with the fact that on the DCC, an industrial site has an obligation on its connection point, and a machine on the site can have a different obligation, or they can counteract each other. So I had a look at DCC. I didn't have a look at RFG yet, the full text with the amendments, but this is not really tackled. Can there be somehow a provision in the text that if there is a discrepancy, one has priority or something, because this remains a big issue for us.
Thank you. So I do understand that you didn't have time to go through these extensive changes that we have published 2 days ago. So please, after, you can step in touch with us after you look into the both legal text proposals and perhaps point out or discuss this with us prior to submitting the final, let's say, comments to both of the proposed draft amendments during the consultation.
Okay, because I had to look at DCC, RFG, but it's really, I mean, I don't want to create problems, but it is because we have some issues with counteracting requirements, and that's, I mean, we cannot do counteracting requirements at the same time.
Yeah.
Okay, thank you.
Thank you. Rodrigo?
Yeah, hi everyone. Do you hear me?
Yes, loud and clear.
Yeah, yes, I will enter a more in the detail of the MPR question about EV requirements. In the case of, for example, AC bidirectional charging, when there is a great variation that implies a active power reduction, can this behavior be controlled by the charging station, or is there is an obligation of the curves to be stored in the EV inverter?
I'm not sure I captured your.
I mean,
maybe you can paraphrase.
All the limits and the curves that have to be followed in case of, for example, frequency reduction or high frequency, etc. There is a expected inverter reaction.
Yeah.
And these curves and all these parameters has to be known by the EV inverter, or can be the charging station act as the control of this inverter and know these parameters to filter the power output of the EV inverter.
Okay, thank you. I think I understand your question better. So as Yorgos explained before in one of the previous questions, we don't separate the supply equipment from the vehicles itself when we request, for example, a capability from the two. This is because of different underlying technologies for charging, because sometimes the converter may be in the supply equipment, like a charging pillar or wall box, but at the same time, it could be the onboard charger within the vehicle. So in whatever situation of the charging, let's say, process, the requirements need to be met. So they need to be met from the charging equipment if the onboard charger is being sorry, if the off-board charger is being used, or by the electric vehicle itself if the onboard charger is being used. And of course, the depending on this mode of charging, the let's say provision of those capabilities should not be jeopardized by the non-functioning part, for example, which does not have which is not using the converter, meaning that, for example, if there is a need to have some communication between the two, the charging equipment and the vehicle itself, it needs to be enabled in order to provide for the functionalities or the capabilities. I hope this answered your question.
Okay, so the requirement at the end is for the couple vehicle and charging station.
Yes.
Okay. Okay. Thank you very much.
Thank you. Jan?
Yeah, thank you. And thank you for your presentation today. First of all, I am really, really concerned that it is not possible to combine different technologies and storages into one ppm. And I'm really concerned because if we, for instance, integrate storage devices into our PV parks or combine it with wind turbines, then we need to add all the capacity from these three technologies together when we order a grid connection. Because if you look at the requirement, then the response that the grid will see as the requirements are made will be added. For instance, in a LFSMU situation where all devices should produce maximum active power at the same time, and this will really prevent us from doing an efficient integration of storage and also the combination of wind and PV. I really think you should consider that. It's really important and could make it very expensive to integrate storage, which everybody needs.
Mm-hmm. Thank you, Jan. But correct me if I'm wrong, but under the current RFG 1.0 rules, disaggregation is sort of more or less automatic. Here we are actually putting limitations to aggregation. And I understand from NSOE proposal for the amendments that this aggregation should take place in full, whereas we have proposed a compromise solution here to aggregate only the similar technologies capacities in order to determine their types. Maybe we're speaking of different issues here, and we haven't established a common ground yet.
Yeah, and my point is, if you have, let's say, 50 megawatt of wind, 50 megawatt of PV, and 50 megawatt of storage,
okay,
then the whole installation should respond as 150 megawatt ppm. If you have, for instance, a low LFSMU situation, and we would probably, let's say, make a 60 megawatt of or 75 megawatt of grid connection, but we cannot do that because we have to respond as 150 megawatt plant, and this is really, really bad. And we should really, really consider how to deal with this. It will,
As
I
per
can say
our
it will
proposal,
destroy. Oh,
sorry.
sorry.
Yeah, go ahead.
Yeah, I will just say it can destroy the business case for us to combine wind, solar, and storage. That is my point.
Yeah. So thank you for this comment, but this is exactly the opposite that we are proposing. We are not proposing to combine the three different technology types in order to determine their response or their capabilities. We propose to treat each technology type independently and determine their type as per the technology. So ESMs would not be automatically combined with solar and wind and behind the same connection point in order to determine the overall power generating facility capacity. That's not what we are proposing.
No, it's not about defining the capacity. That is it's when you look at the, let's say, combined response from all units. Then if you have 50 megawatt of each, then all of them should be able to produce
its own maximum.
Its own maximum. And that is the problem. It should be possible, let's say, to define a limit that I will never export more than in the requirements.
Okay, that is clear now. According to our understanding, this is then subject to the connection agreement, where such a limitation is defined. But it's a case-by-case consideration. It's I don't know. Maybe there are some general provision. Or there's a general provision possible that we can insert it in the code, but we cannot deal with case-by-case considerations in a European network code. And according to the current understanding that we had, is that such details of the, let's say, operational conditions are always set at the and prescribed in the connection agreement itself.
Okay, so you say that that we can actually make an agreement that we act a bit differently from the requirement based on the export capacity with the grid.
I don't know. Maybe there are tangible reasons for the system operator to limit this because of the, I don't know, the grid situations. But I mean, the connection agreements as such are very different from member state to member state. There are different bits and pieces that fit in, and usually any operational conditions like flexibilities and so on are prescribed in this connection agreement, but this is out of scope of the requirements for generators and demand connection code. So I don't know, maybe we can have further discussions separately. We'll also have a look into that, but
I will get in contact with you.
Okay, good.
Thanks.
Thank you.
If I may also add to that, because we're talking about connection requirements to support the system under conditions that happen in the system. So in that sense, we're not talking about the actual operation of the units, whether they are at 50 megawatt each or 25 megawatts or 10 megawatt operational. When there is a disturbance on the system, all units will see this disturbance and they have to comply with the requirements. So if there's a fault at the transmission system, all devices will see the fault. They have to comply with requirements. If there is a frequency disturbance, all devices within that site will see the frequency change, and they have to comply with the according phase based on the requirements. So it's not about what is the actual active power operation at the time, is whether when they see the system, all devices seeing the disturbance, they have to comply and support the system. So we're talking about mostly about these kind of situations. This is not a normal operation where the owner of the site decides how they should operate the units within the site behind the same connection point. I don't know if I can clarifies that. the ideas.
Thank you. And also to complement, let's say that this combined reaction of the 3 different 50 megawatt type of technologies at any one point in operation, I presume situations where you would get from solar, from wind, and the batteries, the when you would have the operation point at 50 megawatt, it's practically very rare, or even maybe even impossible, because we know that these are variable energy sources. So it's a theoretical case, but the capabilities are determined based on the current operation point, which depends on the primary energy source availability. If it's like, depending, of course, on the mode and the parameter that we are speaking of. Okay, but we can dig deeper into this separately. Thank you. Stefan?
Yeah, good morning. Many thanks to the ACER team for organizing this webinar. And as we see, there is lively discussion, lots of things to be clarified. So I'm wondering, as we're just at the beginning of the consultation, what do you propose, or what can ACER can offer if we have a further need for clarification after this webinar? How to reach out to you? And is there a way that ACER can make also sure that, let's say, answers provided to the questions can be made available for all participating in the consultation? What is the best way to proceed, please?
Thank you. So today's recording, where all stakeholders, let's say, questions have been answered, will be published. Then any further clarifications for that, you can reach to our email, which is it the functional mailbox that we use for this one? Otherwise, you can just connect to this relay. You can reach out to this info general ACER. Yeah, it is a functional mailbox. So you can use reach out to us via the functional mailbox. Yeah, whether or not the clarifications could be made available for other stakeholders, I don't have an answer for this. We'll see. We can discuss when you reach out to us. We can discuss what the issue is, and then see on a case-by-case basis whether further, let's say, clarification could be useful for other stakeholders as well. But we can also think of, because after the public consultation is finished, we still have some time to finish the final proposals that we'll send to the commission. And I've mentioned, as I'm also a chair to the Grid Connection European Stakeholder Committee, where European stakeholder associations are also connecting and meeting on quarterly basis, that we might organize separate workshops also after the public consultation, where further discussions could be, let's say, taking place. But yeah, feel free to use the functional mailbox to reach out to us, and we'll see further how to and not to disseminate information further. Okay.
Thank you,
Bernd. Thank you, Bernd.
So good morning. Thank you for the presentation. I have a 20 years experience track on grid forming inverters, mainly for island grids and storage. And it's a real, I want to underline, it's really a paradigm shift going from grid forming to grid forming. Also having a lot of danger for grid stability, mainly in distribution grids. So there's up to now no experience at all grid-connected grid-forming inverters in distribution grids. There has to be research programs about the consequences about this. And I think it's wishful thinking, like Christmas presented by ACER, to start with grid forming inverters with 800 watt with the capability to switch on or switch off grid forming. It's really wishful thinking, but it's beyond reality and the state of the art.
Thank you, Bernd, for your
It
comment.
can be also a danger for Fit for 55 if this requirements is into force too early.
Thank you, Bernd. You can let's say see in the proposed requirements for generators that type A PGMs, which start as of 800 watts onwards, is not mandatory grid forming. But yeah, please do provide any further justification which we can take into account during the public consultation. It would be very appreciated. Thank you. Vasiliki?
Hi, sorry, I couldn't unmute myself. Regarding both the flexible connections and this question by Jan for the collocation. So if I understand correctly, your approach is that we define the maximum connection capacity, and that's enough then for its system operator to treat on a case per case basis on the local needs how this should be applied. But this
sorry, I think this is misunderstanding.
Okay, so for the flexible connections, if I understood correctly, the reply was that the code must define only the maximum connection capacity, and then the rest is a matter of operational needs that is not defined, is out of scope, right?
When you speak of maximum connection capacity, it's not the same as the network code uses the notion. We speak of the maximum power generating module capacity as defined in the connection agreement. And this is different from the maximum connecting capacity. This is out of scope of these network codes. Because what we need in order to determine the type and the concrete requirements, connection requirements on the power generating module is to establish this capacity of the power generating module itself, which may be different from that of the connecting capacity, as you may know. And and we can't address this because this is a case-by-case consideration.
But ideally, there should be a definition also for the other, and then if there are issues or if there are case-per-case needs, then in that case, there should be a case-per-case approach. Normally, this is why we have the European code.
But you have standardized products, off-the-shelf products, and let's say at least for the electric vehicles and the supply equipment, we have fully harmonized now the requirements for the first two types. And imagine if you would start mixing the connection capacity with the capacity of the individual module, and suddenly your off-the-shelf product would not meet the requirements of the connection code because of that. I don't think this is something that we want.
But what I mean is that there should be a direction in the European code on how it should be defined then at the national level, because if the mess that you describe now, if it's completely left to the national implementation, it will be 100 times more.
No, but look, the problem of these local specificities is that the system operator, they need to determine what is possible to connect at certain connection point, and we cannot prescribe this from the European
you cannot
network code
prescribe.
perspective.
You cannot prescribe the share of capacity, but you can give a direction in the code on which parameters should be then prescribed by the TSO, right? Because at the moment it's only the maximum capacity that you mentioned that is described in the code. You can say these parameters need to be described, but then at national level you can decide the share or whatever else. Otherwise,
Okay.
there can be many different interpretations.
Thank you, Vasiliki. I think we have addressed this in the November public consultation. Please look at our
not for the case of
feedback there.
flexible, for
I
sure,
think we
not for
did.
the case for flexible connections.
Not
for sure not.
Are you sure that other 39 stakeholders or 50 stakeholders did not comment on this?
Yes.
You've read the whole consultation folder. Because I think we have addressed it. I have a vague recollection of the comments from stakeholders. I'm not sure which one is it, but
okay.
Yeah, and please use our comment or our explanation or the feedback to that stakeholder, and then perhaps define what if, or please come back to us on how do you see fit this flexible connection issue should be dealt with and justified in the public consultation form as well. Thank you.
Okay, thank you.
Okay. Are there any further comments or questions from stakeholders? If not, then I would apologize for running over the projected end time at 11 o'clock, but I guess it was in your interest to extend the time and stay here to hear from us as to how we could interpret the current legal proposals that we have put forward. I think it was really useful also to us to understand what might be coming from your side in this public consultation, and this gives an indication as to perhaps where certain clarification would be still merited and benefiting the stakeholders in order to efficiently apply the network codes that will be sent to the Commission after we conclude the assessment of your comments. Thank you for the applauses. Thank you for all the exhaustive questions, and thanks to Yorgos as well again for addressing a bulk of stakeholders' comments. Thank you very much, and hope to hear from you during our public consultation. Have a lovely summer. Bye-bye.
Bye.
Bye.